Welcome to this tutorial on plastic injection simulation using the 3D Experience platform. In this video, we'll walk you through the entire process from importing your model to running a full simulation and analyzing the results. Whether you're new to simulation or looking to enhance your skills, this step-by-step guide will help you understand how to optimize your designs for plastic injection molding. So let's get started and bring your ideas to life with accurate and powerful simulation tools. First, we need to import our clutch cover model as a step file by dragging and dropping it into the workspace. A green status confirmation will indicate that the model has been successfully imported. Next, use the compass to select the 3D Experience Engineer role and then launch the plastic injection application. Upon starting the app, the assistant panel will automatically open. Now, starting with the first action part, we need to define the contributing parts for this simulation. Here we'll select the main body of the model. Right-click and set it as plastic. For the second action, materials, we will assign a generic ABS material to the part by simply dragging and dropping it directly onto the model. Moving on to the third action, process settings, this is where we adjust the basic simulation parameters. The app provides default values, but we can customize them if needed. For example, I'll set the melt temperature to 600 Kelvin and the ejection temperature to 380 Kelvin. Which ensures the part can be safely ejected from the mold. The default values are based on the material properties, but they're easy to override as needed. Additionally, during the fill simulation, you can also edit the fill time if necessary. Now for the fourth action, condition, we need to specify an injection location. Every simulation requires at least one, so here we'll select a face as the injection point, indicating where the plastic will enter the part cavity. Before moving to simulate, the mesh is generated automatically for the part. If needed, you can edit the mesh to adjust its density or refine specific areas for more accurate results. Finally, for the last action, simulate, a pop-up menu appears where we select the analysis case. For this simulation, we'll choose Fill Simulation 4 CPU cores, or Pack plus Cool Simulation 4 CPU cores based on our requirements. Once selected, click OK to start the simulation and wait for the results to be processed. After the simulation finishes, we click play in the compass to visualize the results. This allows us to see how the part is filled during the injection process. For example, air traps are highlighted in red, making it easy to identify problem areas, and weld lines can be analyzed further by enabling the Show Min Max Value option. Let's rerun the simulation. In the Results tab, we can first view XY plots, like clamping force versus time. After that, we can see plots such as maximum injection pressure. The graph updates automatically to display the latest data. You can also create section plots to cut through the model and view its interior details. Lastly, the 3D Experience Plastic Simulation allows us to generate a comprehensive report. This report summarizes all the simulation results and exports them as a Word file, making it perfect for documentation or sharing insights with others. And that's how you run a complete plastic injection simulation in 3D Experience with Champion Experience.